All right, everybody, so last time we learned how glaciers form. Today we're going to focus more on how they erode, how they change the landscapes. They've changed the landscapes all over this area of New York State, and we're going to learn today how they do this, how they do that, and what to look for, what evidence. First of all, glaciers, they have many different ways in which they change the landscape. One of them is by what we call abrasion. Rocks can get frozen in the bottom of this glacial ice, and then as the ice moves outwards or downwards, those rocks frozen into the bottom slide, scrape, and scour the bedrock beneath it. And that creates evidence. Another thing they've done, especially in the Adirondacks, is what we call plucking, where the ice, as it flows over the tops of these mountain peaks, plucks rock fragments off. And these rock fragments can be massive, boulder-sized. And you can see here how the glacial ice is plucking the rocks right out of the bedrock and carrying it downhill. And that downhill might be somewhere where we live, here in Fort Plain. Some erosional features that glaciers leave behind. A telltale sign that an area has been glaciated, and you can see it all the way from New York City all the way up north of there, are striations. These are grooves carved into the bedrock by pebbles, cobbles, perhaps boulders carried at the bottom of the glacier, and they often show the direction of the ice movement or advance in that area. Another thing, because of all that scouring of the sediment on the bottom of the ice, it polishes the bedrock. And I have some examples here in the classroom I'll be showing you. The bottom of the bedrock is smooth, shiny, and it does have still some scratches in it, but you'll see how it's polished when I show you those examples. A sediment we call till, glacial till, is formed. And this is simply when the ice melts, the particle, the rock sediments, they don't sort in any way, shape, or form. They're all mixed and often angular shaped, or they have these scratch shapes. And they're not layered either. So we call it glacial till. It's a pain in the neck for farmers in this area. They have to pick the rocks in their fields all the time because these rocks are left over from glacial ice often. Here we see some striations in the bedrock. They show the direction of movement. You can see some large striations moving in this general direction, or perhaps in this general direction, but we're not really sure, unless this was part of the bedrock, not a rock that had been plucked out, in which case we can find compass direction, look for north-south, and generally the ice is going to come from a colder, more northerly direction and head more towards a southerly direction. So we have to look for different evidence too. Here's some striations. They're groovy. You can see them right there in the rock. And some chatter marks. When the glacial ice is sliding over this, you can see it might stop for a little while, build up pressure, and it leaves these little chatter marks all over the ice. Glacial till, you can see unsorted sediments all over the place, little big, all different pieces, different sizes of rocks. Unsorted is what we call that. And here's some glacial polish. These rocks were smoothed by the glacier's flow over the bedrock. You can see scratches in there too, but smooth. You'll see this in New York City, in Central Park. Glacial pavement. This looks like the top of a mountain, and you can see these large glacial boulders here. We're going to learn about them later. And general direction of the glacier's movement. Which diagram best illustrates a cross-section of sediments that were transported and deposited by a glacier? So in this kind of question, we're not looking for something that's layered and sorted. Sorted means, small to big or big to small. Some way, shape, or form, it's a pattern. We're looking for a random selection of sediment, and that is best shown by this first choice here. That would be the best choice for glacial till. Erratics. All right, we've seen these around here. I know they're in some of the farm fields in this area, and you see them a lot when you're hiking some of the trails in the Adirondacks. These are boulder-sized rocks that were dumped by the glacier as the glacial ice melted. They're usually, and not always, a different type of bedrock than the surrounding bedrock of an area. So these boulders can be transported a long ways. You might have like a metamorphic boulder in an area here that's mostly shale and limestone bedrock, and you know this thing doesn't belong. It came from somewhere far away. There's a giant glacial erratic. Another large one. Those trees obviously grew way after the erratic was put there. They're growing up close to it, but those trees are much more recent. Nice balanced glacial erratic. That's pretty cool. The diagram below represents a surface and cross-sectional view of a portion of the Earth 15 kilometers from a mountain range. And you can see some sandstone bedrock. You can see a granite cobble, a granite boulder. The best explanation for the presence of an isolated boulder in this location, and remember the bedrock is sandstone, so these rocks don't fit here. They're like sticking out. They're imposters. And the best choice is the first choice. They were transported there by a glacier. The other choices really don't make any sense. All right, let's focus on valley glaciers. These are also called alpine glaciers. Some erosional features. Well, mountain ranges that were scenic to begin with are now jagged, angular peaks. They're even more scenic in my opinion, but it really does change the shape, as we'll see in some photographs coming up. The glaciers modify river valleys, and they carve out, from V-shaped river valleys, they carve out U-shaped glaciated valleys. Some of these U-shapes are pretty impressive. Now, I'm not sure if this video is going to work. I'll try it. Oh, here we go. So I'm going to skip the noise part here. I don't know if I can, but oh yeah, it does. So the glaciers are growing here in a V-shaped valley over time. They're filling in where the water was with ice. And as they grow and advance downslope, they're eroding the bedrock underneath it. They're carving it out into a U shape. And you can see this must be perhaps an ice age here. These glaciers are growing tremendously. Now at the end of the glaciation, those alpine glaciers retreat back up the valleys and they leave what they had carved out ahead of time, which is a massive U-shaped valley. And you can see it right in the picture there. The river looks underfit for the size of this valley, and it is. You know, the Mohawk Valley here perhaps could be considered somewhat of an underfit river for the size of the valley. But these U-shaped valleys are all over the northern parts of the United States, places that were glaciated. All right, some erosional landscape features of valley or alpine glaciers. All these features have interesting names, sometimes French. These are cirques, semicircular bowl-shaped depressions created as the glacier scours back towards the mountain. Arêtes, these steep-sided, sharp-edged bedrock ridges formed by two glaciers eroding away on opposite sides of the ridge. Great place to ski. Horns, like the famous Matterhorn, 3 or more cirques adjacent to one another on the top of a mountain. Tarns, these are glacial lakes, high elevation lakes produced by glacial scouring, often found in and around cirques. And hanging valleys. Remember that large U-shaped valley just a minute ago? Well, when those smaller stream valleys meet the larger U-shaped valley, they're now way above it, and these are called hanging valleys. Often you'll see beautiful waterfalls, like in Yosemite National Park. And so the top picture here shows V-shaped valley. And here we have some cirques, so that was non-glaciated. Here we have some cirques, which are these semicircular, carved out areas by ice. There's an arête, this ridge shape. This ridge shape is also an arête. There's your steep, sharp horn. And we have our main glacier carving out our U-shaped valley. And these are tributary glaciers coming off the sides. Now, when all that ice melts during perhaps an interglacial period, you'll see it all left behind, all that evidence. Here we have our glacial trough, our U-shaped valley, our hanging valleys with our beautiful waterfalls. There's our horns. Our tarn lakes could be up there where the cirques used to be. And the remnants of those glaciers now left in the form of cirques. There's our knife-edge sharp arêtes. Someday this would be glaciated again. Same idea here. Our horns, our arêtes, our hanging valleys are covered by ice right now, as is the U-shaped valley. There's the famous Matterhorn in Switzerland. And a hanging valley in Yosemite National Park with a beautiful waterfall going over the edge. Another horn right there. Oh, actually, sorry, an arête. Looks to me like it could be part of both. And it looks like a hanging valley with a waterfall somewhere over in here. There's our cirque-shaped area there. Another cirque. So this area would have all been glaciated during an ice age. There's our Tarn Lake down below. Hanging Valley and nice waterfalls. Ah, U-shaped valley. So all these areas are found where glaciers used to be. Nice U-shaped valley. Big U-shaped valley in New Hampshire. I believe that's Crawford Notch, New Hampshire. I could be wrong, but no, that's actually the Adirondacks. 1997. Grinnell Glacier in Glacier National Park, Montana. U-shaped valley. All right, questions on U-shaped valleys. The diagram below presents the surface topography of a mountain valley. Which agent of erosion most likely created the shape of the valley shown in the diagram? And we're looking obviously for the topic we're learning about today, glaciers. And we're going to stop here and label the first diagram of page 13 of your note packet, unless you're in period 1, in which case we won't do that. Here we have lots of shapes, glacial shapes. If you ever see a picture like this, you always want to think, you know, glaciers. Glaciers made this. All these sharp features. All right, moraines, unsorted, unlayered piles of till. There are many types of moraines. We're going to learn about all of them. Lateral moraine. These are till, you know, rock plucked off the sides of glacial valleys. There's medial moraines, which come right down the middle. It's where two lateral moraines of two side glaciers met into one larger glacier. We got our terminal or end moraine, the farthest advance of glaciers, and these are kind of perpendicular to the flow. And our recessional moraines, which show where the glacier, as it was melting back, stopped for a period of time, dropped some sediment. And you can see in this picture a whole bunch of all that stuff. We got our medial moraines coming down here. Whoops, let's go back. I can't draw on this, but at least you can read it. Our lateral moraines are on the sides, medial moraines in the middle. And at the very bottom of the glacier, the end moraines, the farthest end moraine being the terminal moraine. And below that, where there was no ice, the outwash plain. You can tell that point because the sediments there are sorted. And you can see a lot of those features here in the Juneau, Alaska ice field. Get their big medial moraine right there in the middle. This is really cool. And a terminal moraine here, and a nice lateral moraine in the front. And I'm going to stop right there. So I think we've learned enough about erosional features of glaciers.